Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video I will solve some exercises about the complex numbers. I will start by exercise number 1. Write Z in algebraic form in each of the following cases. Z equal to e minus I 7 pi by 6. Here we have Z in exponential form. We write it in trigonometric, then from the trigonometric to the algebraic. First, cosine minus alpha, cosine alpha, sine minus alpha, minus sine alpha. We got 7 pi by 6, 7 pi by 6. 7 equals 6 plus 1. Then 7 pi over 6 is pi plus pi by 6. We are in the third quadrant. Then minus cosine pi by 6, or minus sine pi by 6. Minus here, we got the plus. 2 cosine pi by 6 is radical 3 over 2. Sine pi by 6 equals half. Here we have minus 2. So minus radical 3 plus I. Oh, what about Z equal radical 3 over 2 minus half I to the power 36. First we write radical 3 over 2 minus half I in exponential form. So let W equals radical 3 over 2 minus half I. W equals x squared plus y squared equals 1. Cosine alpha equals real over modulus, and sine is over equals imaginary over modulus. We get alpha equals minus pi by 6. Z equal e minus I pi by 6 to the power 36. We multiply. So we get e to the power minus I 6 pi. Minus I 6 pi. 6 pi is a multiple of 2 pi. Then this is ei 0. Ei 0 equal 1. 1 plus 0i. Modulus of z squared plus 3z minus 8 plus 6i. When we have z and z bar, or z and modulus of z square, etc., we put z equal x plus iy, and we calculate x and y. So if we put z equal x plus iy, modulus of z square equal x square plus y square, 3z 3 into x plus iy equals 8 minus 6i. Real equal real, imaginary equal imaginary. X square plus y square plus 3x equals 8. 3y equal minus 6. What do we conclude? Y equal minus 2. Substitute y equal minus 2. We get x square plus 4x plus 4 plus 3x equals 8. Leads to x squared plus 3x minus 4 equals 0. Here we have x equals 1, or x equals minus 4 over 1 equals minus 4. Z equals 1 minus 2i, because y is minus 2 always, or z equals minus 4 minus 2i. Exercise 2. Given the points A, B, and C, by two ways show that AC equals minus 3AB. First way, we find the coordinates of vector AC and vector AB. AC of coordinates xb minus xa and yb minus ya. xc minus xa, this is xc minus xa, xc minus xa, 7 minus 1 equals 6. YC minus YA equal minus 9. So vector AC of coordinates 6 minus 9. AB, XB minus XA and YB minus YA. We got AB minus 2, 3. Now, if we multiply AB, vector AB by minus 3, we have to multiply the coordinates of vector AB by minus 3. We got 6 minus 9, which is AC. Then vector AC equals minus 3AB. Second way, we find ZB minus ZA over ZC minus ZA. This is equal minus 1 over 3. And minus 1 over 3 is 1 over 3 EI pi, which is equal to AB over AC, EI, AC, AB. So 1 over 3 equals AB over AC, leads to AC equals 3AB, and angle AC-AB equals pi, so AC and AB have opposite senses. AC equals 3AB with AC and AB have opposite senses, then vector AC equals minus 3AB. Exercise 3. Given the points A, B, C such that AB equals radical 3AC and AC-AB equals pi by 2 mod 2 pi. We have to write ZA minus ZB over ZC minus ZB in exponential form. We have the angle between AC and AB, and AB with respect to AC. So we have to what? To draw a figure. Then we calculate ZA minus ZB over ZC minus ZB. If we have AB and BC, where AB, BA, BC, we can calculate this fraction. So this is the figure. AC-AB is pi by 2, 90. AB equals radical 3. AB equals radical 3 AC. AB equals radical 3 AC. And what about BC? Since this triangle is right at A, we can calculate BC square as AB square plus AC square. Let us see. BC square equals AB square plus AC square. But AB square is 3AC square, then 4A square, 4AC square. BC equals 2AC. BC square equals 4AC square, then BC equals 2AC. BC equals 2AC. What do we conclude? Then this side equal hypotenuse divided by 2. Then the triangle ABC is semi-equilateral triangle, and the angle at B is pi over 6. Since the side facing pi over 6 is equal hypotenuse over 2. Hypotenuse over 2, property of a semi-equilateral triangle. Then A equals 90, B equals 30, C equals 60. ZE minus ZB over ZC minus ZB is BA over BC, EI, BC, BA. BA over BC, BA over BC. BA over BC. BA equals radical 3 over 2 BC. Then we simplify by BC, we get radical 3 over 2. And the angle BCBA, BCBA in the opposite sense, this is minus pi by 6. Then radical 3 over 2e minus I pi by 6. This is the exponential form of ZA minus ZB over ZC minus ZB. In algebraic form, ZA minus ZB over ZC minus ZB, we substitute, we got what we... Exercise 4. Given z equals minus 2 plus 2i radical 3, calculate the natural integer n belongs to 6774 for zn to be real, to be a real number. So we write z in... First, we have to find an argument of z, modulus of z, argument of z. So alpha equals 2 pi by 3, 2 pi over 3. Argument of Zn equals n argument of Z equals 2n pi over 3 mod 2 pi. Mod 2 pi. For Zn to be real, we should have 2n pi by 3 mod 2 pi equals k pi. equals k pi, and here we have mod 2 pi, k pi, k prime pi plus 2k pi or minus 2k pi. This is what? This is a multiple of pi. So 2n pi over 3 equals pi mod pi or k pi, the same. Pi mod pi or k pi, the same. Then 2n pi over 3 mod 2 pi over 3 equals pi mod pi. If we take mod 2 pi to the other side, we got mod pi. It means 2n pi over 3 equals pi plus k pi. Simplify by pi, we got 2n, and we multiply by 3, we got 2n equals 3 into 1 plus k, n equals 3 into 1 plus k divided by 2. We have to calculate n. Integer, n is an integer in 74. N between 67 and 74. Substitute n, 3 into 1 plus k divided by 2. We multiply by 2, both sides, we get 134 less than 3, 1 plus k less than 148. Divide by 3 and subtract 1. We get k between 43.66 and k between smaller than 48.333, etc. So k should be 45. Why 45? Because 1 plus k should be divisible by 2. 1 plus k should be divisible by 2. If k is even, 1 plus k is not divisible. 1 plus k will be odd. So 1 plus k is not divisible by 2. We have to take the odd values of k. Odd value of k plus 1 will be even, divisible by 2. And n equals 69.72. If we calculate k, we substitute k, we calculate n. Exercise 5. Calculate cosine square pi over 8 minus sine square pi over 8. We know that e to the power I pi over 8 square, e to the power I pi over 8 square equals ei pi over 4, because we simplify by 2, ei pi by 4. Let us see. ei pi over 8 square equals ei pi by 4. ei pi by 8 is cosine pi by 8 plus I sin pi by 8 square equal cosine pi by 4 plus I sin pi by 4. Expand cosine square minus sine square. Why minus sine square? Because a square and b square is minus sine square. I square is minus 1. Minus square plus 2i sin pi over 8 cosine pi by 8. So then real equal real. Cosine square pi over 8 minus sine square pi by 8 equals radical 2 over 2. And 2 sine pi over 8 cosine pi by 8 equals also radical 2 over 2. No, we need to calculate cosine square pi over 8 minus sine square pi by 8. This is radical 2 over 2. Thanks for following and good luck.